In the next few minutes, you will learn how to eliminate unnecessary machine idle time and why eliminating idle time will save money and fuel while contributing to the longevity of your equipment. But before we begin, let me talk about the theme of this training. It all starts with you. Just like the operator in this poster, you hold the key to achieving the benefits of no idling. There are many variables affecting machine efficiency, including design and application, but the most important variable is the operator. Place a machine in a skilled operator's hands, and the result will be more production with less wear and tear on the machine, and an optimization of the fuel consumed. Think about when the machine isn't in any hands at all. Think about a machine sitting idling through lunch. Fuel is consumed, and no work is accomplished. Bad deal. Similarly, a machine idling for prolonged periods is a wasted machine wasting fuel. So think about the lack of productivity of an idling machine. Then think about 3 simple steps. First, shutting off at lunch. Second, limiting continuous idle to 5 minutes. And third, limiting cool-down periods to 3 minutes. These are the 3 steps to successfully limiting idle time to only essential idling. We've mentioned that limiting idling improves your efficiency, but it's also good for your equipment's engine. The modern diesel engine is really a remarkable piece of technology with sensors and built-in intelligence that constantly monitors fuel, air, and temperatures so that it can squeeze the last bit of energy out of each drop of fuel. And the modern diesel is at its best when it's working. During idle, a modern diesel doesn't combust fuel as efficiently, which, over time, can be detrimental to component life. Now that we've discussed how idling is bad for efficiencies and bad for engine life, let's talk about the third bad. Idling is bad for the pocketbook. Often we hear the question, how much fuel is consumed during 1 hour of engine idle? Although the answer varies based on engine displacement, vintage, and condition of the engine, the rule of thumb is 1 hour of idle equals 1 gallon of fuel burn. This may not seem like a lot of fuel, but it adds up quickly. If an average machine working 2,000 hours a year idles 40% of that time, then that one machine consumed 800 gallons in just 1 year of idling. Now, multiply 800 gallons per year of fuel burned idling by the number of machines in your operation and by the number of years you keep machines in service, and you'll understand that a sizable percentage of your fuel bill is spent on idling. But fuel burned during idle isn't the whole story, or even the biggest costs associated with idle. The bigger costs are depreciation and repair and maintenance. Unlike your automobile, where usage is based on an odometer reading, off-highway equipment use is based on the hour meter. And anytime the engine is running, the hour meter is recording usage. On the used equipment market, there is no difference between an hour of working time versus an hour of idle time. The same is true of maintenance intervals, also based on the hour meter. So when it's all said and done, an hour of idle time costs just about as much as an hour of working time. The big difference is you get paid for work done, whereas idle time is money headed in the opposite direction. With so many good reasons not to idle, you may be asking yourselves, why is idling so prevalent? This is a great question, deserving further discussion. We titled this discussion, It's a New Day, because we firmly believe that people who own and operate construction equipment are smart and pragmatic, and that the practice of letting equipment idle is a carryover practice from earlier times. Back in the day, there were several factors that made diesel engines harder to start than modern diesel engines. Pistons were constructed of cast iron, fuel pumps were spring-loaded, cooling fans mechanically driven. All of these parasitic loads on the engine, coupled with single-weight engine oils, made rotating the engine during starting more difficult, contributing to more stress on the starting system and more difficulty with cold starts. When diesel was 50 cents per gallon, the prudent practice was to start a machine and let it run. But today, the new day, the modern diesel engine is designed to start using very little crankshaft rotation. Thus, the fear of restart is really unfounded. But the gain from reducing idling is very real. Early in this discussion, we talked about the operator being the most important factor in machine efficiency. Eliminating unnecessary idle may be possible by just rethinking the need to idle and making some changes to your daily routing. What comes next is something you're probably already doing, which is climbing in your machine each day with the intent of doing a job you're proud of. An efficient operator is smooth, keeping his equipment within its operating envelope to maximize production and efficiency. Work the machines. Use the right machine for the job. Cut down on wasted movement and continue to take pride in getting the most out of yourself and your machine. Many of the machines you operate may be equipped with the ability to measure idle time. Ask your managers for feedback so that you can benchmark yourself and measure your progress. We hope you found this session informative and that you've learned how to limit non-productive idle time. It's important both technically and financially. If you have any questions, please direct them to management or send your questions to noidling@komatsuna.com. Thank you for your time and happy no idling.